Hello everyone, let's see if we can tackle this problem here. For the following exercises, decide if the function is continuous at the given point. I think I cut something off. Is continuous at the given point. If it is discontinuous, what type of discontinuity is it? Okay, this is from Openstax Calculus Volume 1. One thing I'm going to do is see what happens if I factor the numerator here. But also, let me point out that if I put in x equals 1, what do I get? I get 2 times 1 squared minus 5 times 1 plus 3 divided by 1 minus 1. And that gives 0 over 0. Which is undefined. So at least we know x equals 1 is not in the domain. So it should be, it is a point of discontinuity, or it's a number where the function is discontinuous. And also, since the numerator is 0, when I put in 1, I know that x minus 1 is a factor of the numerator. And I have x minus 1 in the denominator. And since I have one of the factors in the numerator is x minus 1, it'll be easier for me to factor the numerator. X times 2x makes 2x squared. Negative 1 times negative 3 makes 3. We can see that is, in fact, the factorization. Those cancel out and give us that we have y equals 2x minus 3. However, x equals 1 is still not in the domain. The domain of f is equal to all x not equal to 1. And I know that this might seem like overkill, which, why not? It is, maybe. But do I need to sketch the graph? And, the question is whether I think if that's easier or not. I think in this case, it makes the whole thing a little bit easier to sketch the graph. Now, that was just for this particular problem because I had an idea that would happen. And so let's keep going with this and sketching the graph. The y-intercept is negative 3 and the slope is 2. So sometimes I get too confident and, oh my gosh, let's see, is this correct? Yeah, I'd say so. Okay, why not? So I have m is equal to 2, b is equal to negative 3. I feel like I'm getting this now, but at 1, there's a hole in the graph. This seems to be 1, negative 1. I'm going to put the hole there because the function is undefined there. And that tells me, what did it ask? So it's discontinuous at 1, and that is a removable discontinuity. Let's talk about that. Let me write down that statement and then talk about that a little bit more. So f has a removable discontinuity at x equals 1. For me, the removable discontinuity, if I sketch the graph, is I look at the picture and I see that hole in the graph. So removable discontinuity should be a place where the limit exists. So we can walk through the definition of continuity, and at x equals 1, x equals a. So the first one is that f of a exists or is defined. That means, is a in the domain? Well, in this case, it's 0. 0 is not in the domain. F of 0 is undefined. The second one is that the limit exists. And in this case, the limit does exist. And the third is that the limit as x approaches a equals f of a. So for a removable discontinuity, f of a might be defined, but it doesn't have to be. The limit exists. The limit exists, but it's the third one. The limit of f of x is not equal f of a. Limit of f of x has to equal f of a. For removable discontinuity, that doesn't happen. the limit doesn't equal the value of the function. Here I've written down up here a definition of removable discontinuity. The limit exists, and okay, but it's discontinuous. So the picture is the one we have here. The limit exists. You can see the limit exists for removable discontinuity, but this time the function's defined above. So there's like this dot where we have the value of the function. Okay, and so I guess that pretty much does it. I know I sort of jumped around on the screen a bit. And I wrote down more stuff than I had to. Like I put down the definition of continuity, and that was sort of an afterthought. Maybe I perhaps should have even started off with that somewhere written down. But okay, I think that is enough for this problem. Goodbye.